Welcome to Puddlecast, where we discuss safety, water, environment, and career development topics. Let's jump in.
Well, welcome to another edition of our Puddlecast. We got Joseph Brascher Jr. in the house. Welcome.
Thanks for having me, Nate.
Yeah, you betcha.
Appreciate it.
You bet. Tell me a little bit. So you have a similar stormwater career path that I did. You work with your father.
Yes, I do.
So tell me a little bit about how you got started in the stormwater industry.
How much time do you have? No,
Yeah.
no,
That's all right.
no, yeah. So I actually, I went to St. Martin's in 2016. So I started going to school there to get a civil engineering degree. And so my dad's been working in the stormwater industry for about 35 years.
There you go.
And his partner, Doug Barline at Clear Creek Solutions, he's been working in the stormwater industry for about 60 years almost.
Okay.
So they have a lot of experience between them. So eventually he just said, hey, why don't you come just on board and work at Clear Creek Solutions? And I said, okay, sounds like a good idea.
Yeah.
And I love working with my dad. I don't know if it works
That's
for
great.
everybody.
No, that's
but
good.
like, we're just like, we think a lot in a lot of ways, but we're also very complementary in terms of, I think a lot of like marketing materials, educational materials, things like that, ideas and things like that. And he knows his stormwater stuff so well.
Awesome.
And we really just work well together, and I love it. I wouldn't do anything else. So
Right on.
and of working with him, he actually has a background in computer science and physics.
Okay.
So he actually is not a full-on civil engineer, but he's worked so much in the industry. He's worked on so many engineering projects that he could definitely pass for that at this point. So,
well, I know he blew my mind. I mean, I was trying to figure out what stormwater was, and so I was going to these meetings, and he was talking about modeling, and I was just trying to figure out, man, I know water runs downhill, and I know it goes into catch basins and stuff, and I'm supposed to do something with it, but he's talking about doing all of this modeling for jurisdictions and how to figure out how to manage this growing need for this volume control of what's building on our impervious surfaces. Yeah. And I'm sure a lot you guys do modeling all over the world for different jurisdictions and different entities. Maybe take me from where your dad was when he started to develop the hydrology models and what are the influences now going into those systems?
Yeah, amazing question. So when he kind of started out in the 90s, people were sort of kind of getting into things like continuous simulation, but the hardware wasn't there. Like computers were just, you're talking about late 80s, early 90s. Yeah. Computers are not quite there yet. Doug Barline talks about how he had to use they're called stacks or something. He had to put them into a DOS machine to run HSP. I mean, totally crazy stuff. And he said it would take days and months to do like one model run.
Wow.
And people talk to me, oh, WWHM is slow. You want to see what slow is? Go back to that. That took days.
The green box.
WWHM is lightning fast for what it's doing, running 70 years of data. So, but the idea was, how can we get HSPF into a usable form? I don't know if you've ever seen an HSPF UCI file. Or HSPF input file. I mean, it might as well be Egyptian hieroglyphics. I mean, the thing is crazy. No regular engineer, I would say, could be expected to learn this thing. Okay. And it has to be perfect. The HSPF input file has to be perfect for HSPF to run properly. And that's what continuous simulation is built off of, is HSPF. Okay. Which is what does the calculations for every time step for what I mentioned. Soil infiltration, runoff, all those things are calculated in the HSPF program. But
so it's calculation, not just what's at the surface, but what's going into the ground.
Everything. What's raining, what's going to the surface, what's running off, what's infiltrating. I mean, and there's a whole bunch of factors that go into that. And it's in WWHM. If you open up one of the options, you can see what are all these I forget what the exact name is called, but there are all these different factors that you can modify that determine how quickly the water does all these different motions every time step. Okay. And it's insanely involved. It's insanely complex. So, but normal people could not really use HSPF. It's very complicated, very difficult to construct a file properly. So the idea was, and this kind of happened around the late 90s, is how can we develop HSPF, but make it user-friendly to some degree. Make it so people could actually use it. Okay. So in the late 90s, the very first version of the Western Washington hydrology model was developed. And this took HSPF, but put a user interface to it and allowed people to actually utilize the power of HSPF. So when someone's building a model in one of our hydrology models, it's building an HSPF file in the background.
Okay.
But the user doesn't see that. So the user doesn't have to worry about it and can just build their model. And we're creating the HSPF input file and then creating the results in the background, essentially. Obviously, all the analysis features, we had to develop. We have to develop all of that. But it's harnessing the power of what this HSPF is. And so the users can now utilize that. They can now take advantage of it and do it in a way that's simple and not super complex to try and figure out, because he's obviously a wizard at, he could build HSPF input files. I've looked at it. It's insane. If you create a report in WWHM 2012, you can see what the HSPF input file looks like, because sometimes when people have problems with their software, we need to see that to find out why there's an error or something like that. Sure. But it's crazy. Wow. I mean, it's really involved.
So take me into some of these meetings that you guys are going into, and you're in maybe with a client, or maybe it's a committee of people. What are they asking you for? What are they asking you to consider in this modeling that we haven't had to factor before? We're doing so many more different types of infrastructure pieces, whether they be bioretention, permeable hard surfaces. What are some of these things that they are asking your model to output? Yeah.
So recently, for example, in California, it's a lot of different ways to calculate the effectiveness of LID elements. Okay. So basically, in California, they kind of have a point system for how many LID elements you use, and how that can give you runoff credits, essentially, to not do as much mitigation. It depends on what the jurisdiction wants, but that's one of them, the LID aspect of it. Some of these, for example, we're working on different tools that allow you to simulate climate change functions and extreme events, and use University of Washington or global climate data to kind of simulate what's going on, what could happen in the future. People want to know, what if there's this sort of evolution or change in rainfall? How can our facilities handle that? So that's one.
They're asking you to be a little bit more predictive then.
Yeah, actually you'll be a little more predictive. And you know what they say about weather and prediction. It's very hard. So we're working with some of the top people to figure out what are the different models for prediction, and then really we're just putting that tool into some of our software now for, if jurisdictions are curious how our facilities are going to hold up in 40 years, can we determine that? Yeah. So that's been a big focus recently. People have been kicking that idea around for a long time, but it looks like we're kind of putting some of that into practice. Interesting. We have another software package called WIM-SWIM, which WIM-SWIM combines HSPF, so the hydrology calculations of that, with the hydraulic capabilities of EPA-SWIM. Okay. So if people have ever used EPA-SWIM, it's a free open source package provided by the EPA. We have a whole tutorial video series on our channel where we go over how to use EPA-SWIM. Okay. But basically, EPA-SWIM's hydrology is not so good. Hydraulics, great at analyzing hydraulics. Okay. The hydrology is basically useless in EPA-SWIM. Something like WWHM, amazing hydrology, there's no hydraulic capabilities. So we said, well, can we combine these together so people can model their entire project, essentially, from conception to end in one software? Okay. And that's what something like WIM-SWIM is. So you can have land use basins, they generate runoff, and then you can tell it, hey, it's going to go to these culverts, these outfalls, and then to a detention facility. And you can model stormwater events just like you can in EPA-SWIM. You can do all the same things, but now you can also model the hydrology. Interesting. So it's an insanely powerful tool that some people are utilizing, because it's a pain to export. What you essentially have to do is export hydrographs from a continuous model, bring it into EPA-SWIM, individually run those hydrographs to get your hydraulic data and what is happening with your hydraulic system. Go back to your continuous software, make the changes, re-import. I mean, it's a very laborious process. But we found a way to integrate it all into one. Okay. And this is a commercial software package that we offer. So this isn't a free jurisdictional one, but was one people were interested in being able to do. We've had a lot of questions about, well, how do I integrate my hydrology with my hydraulics? Because it's not one or the other; they're related.
So and because the hydrology is so different around the country, around the world, how are certain jurisdictions or certain regulatory authorities are they asking you to use their specific rainfall data, or are they pointing you to places, and then how do you integrate that?
Yeah, exactly. So like in the west coast of the areas where our models are provided, we use their precipitation data. And so we've gone through processes where we contact people at the local jurisdictions, whoever's in charge of the precipitation data, we get it from them. And then we have to make sure it's all accurate. So we have to go through all the data, because there'll be times where tipping bucket didn't work. There were freezing events. And we have to then vet all the data, essentially, find places where there's holes randomly. And then that's what goes in our software. But if you're somewhere where our software is not provided, a place like NOAA is really good. You can get good precipitation data. Sometimes the jurisdiction provides it. There's really not like one unified way that people do it.
Yeah.
It's really kind of surprisingly cobbled together.
Yeah, and I find that from just a practical standpoint is it is difficult for me to go around the country and know, oh, you want me to design to the 2-year 24. Now you're telling me you want me to design to the 100-year storm event, and the variability of what methodologies they're using, if they're just using the rational method or they're using some other type, like what do you see? Are we getting closer to being consistent across the board, or is it just all going to be variable?
I don't know if we're getting close to being consistent.
Okay.
Last year for a project our company is working on, I went through all 50 states' stormwater requirements. So that was quite a laborious project. Yeah, I went through all of them.
How'd you sleep?
I didn't. No, I'm kidding. No, yeah, I went through all 50. I was like, what are the states doing? And so I downloaded whether it was their major cities' stormwater manuals, because each city has their own.
Yeah, you bet. No, I get it.
So it's like each county, each city has their own stormwater requirements, and then the state will have one. Yeah. And so I was like, this is insane. But a lot of the times, what I found, about 90% of the time, it was some form of rational method or SCS with, we want you to use these rainfall types events and model to these
or predetermined factors or whatever. Yeah.
And model to the 20, 100, 80, whatever year. Okay. Typically was the general approach for stormwater detention. Sometimes LID mixed in here or there. Outside of where we operate, rarely continuous, but New York State's kind of actually diving into continuous stuff, which is very interesting. When I was scouring through I think it was the New York State Stormwater Manual that was released last year. I was scouring through it, and they actually referenced the WWHM and said that they were thinking about moving towards continuous. The problem is it is tough to. Well, it's tough to get governments on board like consistently with anything. I mean, let's look at where we are today. Right. But in the stormwater world, it's even worse. I got it. I mean, it's just bad. Like we only use this BMP here, and we only have this. You know, we're special this way, and from a person that works in multiple locations, it gets very difficult. It's so nuancey based on the market. You're so correct. I mean. Just from within different California jurisdictions that are next to each other, they want different requirements because people have different reasons for why they want to do this, and they all have their stormwater boards and they all have their people. And so you get so many opinions involved, and sometimes that's a good thing because people have good perspectives on stuff. Right. But in terms of like getting unified approaches, not a good recipe for that.
Or getting through a meeting without people having to argue and have their feelings hurt.
Exactly. Yeah. We haven't had too many of those instances, so luckily.
That's good.
Yeah, exactly.
It's been a while since I've had a chair thrown at me, but it does happen.
Gosh. Never had it. It's hard to have chairs thrown at you at virtual meetings. So.
This is true.
This
is true.
Yeah.
Well, what do you see going forward, or what do you see as the future? How do you see AI playing into this as we go forward? What's the next major frontier for this?
So AI is such a crazy, weird word because it's thrown around a lot. Yeah. Really, what AI is just a really centralized collection of data we already have. Yeah, right. Like, there's no such thing as like information that hasn't come from a human mind. Sure. It always comes from a human mind. And so I don't know if you're annoyed, but like when I go on Google and they give you that automated AI response, I don't know. I have a dislike for it. But
you bet.
Really, what AI is becoming it's just a collection of the data we already have. Right. And so we could even say something like our auto pond feature uses AI to model your pond and stuff. But really, it's a lot of computer programmers working really hard to make something that can just respond and output information.
Yeah. So I guess going back to what I was saying earlier about everybody.
Sorry if I got
having,
off track.
No. It's
Yeah,
okay.
yeah.
Because it leads me right to where I was trying to go, is that I'm a new jurisdiction. I recently now feel that stormwater is important for us to start to take on.
Yeah.
Where am I going to go? I'm going to start talking to these things, right?
Yeah.
That are going to start to output this information. Well, where is that repository of information? And so sort of spinning back to this whole thing about maybe where it's going, or even reverting back to where we are, bad input in is going to generate bad input out. And so having control of where we're sourcing the data and what we're trying to reach in terms of an objective, I think is so important with these models. They're guidance tools that help you make decisions on a site, but you also have to adjust to site-specific criteria.
Absolutely. Yeah, I guess like there's no one easy answer, because so many different, let's just take the US for instance, so many different climates, so many different kinds of, I would say even economic differences between,
you bet.
Like places there's some places in the South where it's like it's more difficult for them economically to build like expensive facilities. But then you got Silicon Valley, which just like, money seems to flow out everywhere.
Yeah.
They can tax their jurisdiction for a lot of money. So there's economic
and different
challenges.
Philosophies.
And different philosophies.
I want a pond above the ground because it looks like a pond and I can see it. I want to put it under the ground because I want to use every piece of land that's there. Land is valuable. I don't want the water to go to the ground because it's going to hit our aquifer and we don't have enough depth to groundwater to take the pollutants out. I want it to go to the ground because it makes it disappear at the surface, right? So philosophies drive
I've talked to a lot of stormwater designers from like the East Coast, for example, and they're like, well, we just use infiltration for everything. And we're like, we have glacial till here.
Yeah.
There's no infiltrating in the glacial till. We can't do it. So we have to find other ways.
Yeah.
And so it's like, because even environments are so different, you can't really have one cohesive approach for everything. But we do believe overall that continuous simulation is just superior to every form that's come before.
Because it's taking real data.
Exactly.
Right?
It's real information.
Yeah, okay.
To us, it's kind of like a no-brainer.
Yep.
But when we explain to people who've been using different methodologies for 30, 40 plus years and are good engineers and they know the methods very well and have the best of intentions, they're like, well, why should we change?
Yeah.
Especially when that change will cost more money.
Yeah.
Their facilities will likely be bigger.
Yeah.
A lot of the time.
Yeah.
So it's tough to convince people that you need to change. Also, it's going to cost you more money.
Yeah.
And you have to change the way you've been doing things. It's a very tough pitch.
Yeah.
The only way, though, that people will begin to see it is if their old ways start to cause problems.
Yeah.
So like in Asia, for example, a lot of growing urbanization, in growing population, or sort of the westernization of Asia. And in terms of, these really crazy monsoon seasons, they went, we can't do things the way we were doing before. We've got to look to something else. And so places like Korea, for example, are really, as they're emerging as a nation, especially in the global market, and they're moving out of that developing nation status, when we have to find better ways to preserve our stormwater, right? They're starting to tackle these questions. The U.S. was kind of tackling these questions 50 years ago with like the Clean Water Act in the 70s, for example. But a lot of countries like India too, where they're just starting to now tackle these questions. And that's nothing against them. They're very good at what they're doing, but they're kind of moving into this realm and they're like, what do we do?
Yeah.
And how do we best mitigate these things? And they're finding old methodologies unsatisfactory.
Yeah.
And so, we present at conferences or we go to people and we go, hey, we think this maybe would be the way forward. We think this is much more accurate than anything that you've been doing before. So we try to present that. We try to give people the information on that. But, as with progress in anything, it's always not going to be, super exponential in the beginning.
Well, Joseph, you and your company are great teachers and trainers of information. For people that are just getting started into this, what do you suggest? How do they start understanding how this model is used, or the information that the model outputs for them to make decisions?
That's a great question. So I have two kind of prongs to this. One is how it's being taught in college.
Okay.
So, for example, a lot of people, what they learn in college, it's all the single event stuff, which you should learn that stuff too. You should learn all that well, but they're not getting taught anything about continuous simulation. So when they get into places where they have to use these things, it's a different way of thinking. It's a completely different way of thinking. You're not thinking about just volume. You're now thinking about durations of flows, and you're thinking about matching, flow duration and thinking about a range of flows. It's a completely different mindset.
Isn't that just a great statement? Stormwater management is just not linear.
No,
it's not linear.
No, it's
there are too many variables.
There's so multifactorial. There's so much going into it.
Yeah.
And I think what's given to people in college is a little too simplistic. Now, colleges here in Western Washington, they'll actually expose you to continuous because that's what's used in the industry.
Gotcha.
But like when I've talked to people from other places, they're not exposed to it at all. And so it starts there. People need to be exposed to more than just one way of doing things. Even if it's not used there, people need to know, I think. And secondly, that's why at Clear Creek Solutions, we kind of created our hydrology education area on our YouTube channel. All of that's free. And then we have paid for stuff as well if people want to get more involved with courses and things like that, learning about HSPF. We have an entire HSPF course. So if people want to, purchase that and spend 4 hours learning about HSPF, they can. We also do workshops for jurisdictions. They'll request it as well.
Yeah, you bet.
But we have tons of free information because I think it's important just to get the information out there in general. So I don't care about just people paying us to do it. I just want people to have the information.
Yeah, and for those of you listening, if you need to get that stuff, and we'll get you through to the academy, but where do they go to find this stuff for you guys? Where do they go to get that?
ClearCreekSolutions.com or Clear Creek Solutions YouTube channel.
Your YouTube channel.
We're some of the only people talking about hydrology stuff.
Hey man, stormwater geeks do stormwater geeky stuff. That's what's happening.
Yeah, exactly. It was like 5 years ago. I was looking up information on these topics, and it wasn't that the videos were bad, or it just like simply didn't exist.
Yeah.
Like it's really crazy. Like if you search topics on hydrology on Google, we're the first stuff that comes up. I'm like, how could we have been the first people here? But here we are. So
good for you.
I was like, when I started making educational content for Clear Creek Solutions, I'm like, am I stupid? Like, is no one gonna watch this? But sometimes you have to take a chance if you're gonna be the first to the thing, and that's why. And you should watch all Nathan's stuff, and then after watching all Nathan's stuff,
either way, we're gonna tie it all together because it's so important to get this baseline. And being decision makers on pieces of property has to do with this base foundation.
And it's like now we have a channel that is a small, it has 1.5 thousand subscribers and what I consider to be a very, very niche thing.
Sure.
I'm like, I think that's pretty cool that people were hungry for the information.
You bet.
And we just want to teach people how to use the software, what the basics are to this stuff, explaining, what goes into these things. We have a lot of videos on green cities and LID as well.
You bet.
We want to teach people about that. So it's not even about like a lectured, rigorous thing. We just want to expose people to the information.
No, it's great. It's super great information.
Yeah.
Joseph, thank you so much for being here, being part of Puddlecast.
Thanks for having me on.
All right, man.
Appreciate it.
We'll talk soon. Catch us again next time on our next Puddlecast. Thank you very much.
Thank you to today's special guest. Join us again on the next Puddlecast.